This topic is called permutation, right, and combination. What is the meaning of permutation basically? The meaning is counting, right? That's
Yes.
meaning is counting. How do we count efficiently? Right, using the two fundamental principles. The first one using and the second one using or. And means if you take two or more people together, or we'll take the objects together, that is and. If you take one if we count one at a time, right, we'll see or. But remember, or means what should be here? Should be plus, not into, right? Here should be a into. Do you know why? I'll give an example why I'm saying. Let's say, there are people, there are three members, okay? N equals 3 and R equals, let's say, there R is 2. Have you heard this one? What is NPR?
Hi,
Right?
yes.
NPR means what?
N factorial by n minus r.
Now, what is the meaning of NPR? Arranging. What is the meaning of this NPR?
Arranging.
Arranging n members, arranging n objects or n members in two different slots. Two different slots.
Slots.
Right? So, what is R here? 2. What is N here? 3. Now, there are two slots are there. And how many people are there? 3 members are there. The first slot, how many members can sit at a time? How many members at a time can sit in the first slot? The first slot can be occupied by how many members at a time? Only one member, no? Only one member, right?
Yes.
No, one slot at a time, let's say one chair, right? One chair at a time, how many members can sit?
One chair, one member can.
One member can sit at a time. So I can say the member 1, the person 1 can sit, or person 2 can sit, or person 3 can sit. Make sense? Correct? No. Or means what here? Plus. So how many ways the first chair can be occupied? How many ways the first slot can be occupied? P1 can sit, or P2 can sit, or P3 can sit, which means how many ways can occupy? 3 ways. So what I am doing, I am adding here, no? Different chances I am adding. The first way, second way and third way. There are 3 ways altogether. But keep in the mind, at a time, how many members have taken the chair? Only one at a time. Right. So now
Yes.
go for this different slot, next slot. Next slot, how many ways are possible? Any one person has gone to the first chair. So how many members are available for the second chair?
2 members.
Any two, right? So there are 2 ways. Any one between two can sit. There are 2 ways. Now you tell me, should I multiply them? Should I add them? 3W and 2, 3 ways and 2 ways. What should I do? Should we multiply? Should we add?
We should add.
No, we should
No.
multiply.
Okay.
Do you know why? Do you know why?
No.
Because I need these two slots together can be occupied. At a time, the two slots can be occupied together. Together means what? Multiplication. And also there is a concept called branching out concept. What is the meaning of branching out concept? Let's understand. Okay. Let's say how many were there? The slot, two slots, no? Let's say P1 sat at the first place. Okay. The person 1. So for the second slots, how many are availability is there for the second slot?
2 available.
2 availabilities, right? So I can say if P1 is there, what should be the second? P2. If P1 is there, what about second one? P3. Correct, no? Now,
Yes.
it's quite possible P2 can be here the first slot.
Yes.
Correct, no? P2. So again, how many ways?
Two.
P2 is the first slot. What about the
P1 can
second
be.
slot now? Ah, P1
P1
and
can be there.
P3.
P3 can be.
Super. Now, first slot can be also P3 also, no?
Yes, sir.
So what should be the second slot then? P3 the first
Uh,
slot. What about second slot then?
P1 or P2.
Super. P1 and P2.
P.
Makes sense what I'm talking about?
Yes.
Now, so how many ways all together? 1, 2, 3, 4,
4,
5,
6.
6. So can I say for every one way here, further how many branches are there? Two branches.
Hmm.
Correct, no? So how many can the first place can be the first place can be occupied how many ways? Three ways. That's why 3 into 2. Correct?
Yes.
6 ways
Yes.
altogether. So why I am multiplying? Branching out. For every one way of the previous slot, I am finding multiple ways for the next slot. Make sense? If P1
Yes.
if P1 occupies the first slot, for the second slot we have two different ways. If P2 occupies the first slot, I have the two different ways for the second slot. If P3 occupies the first slot, I have again two different ways for the second slot. That is called branching out. And that's why I'm multiplying.
Yes.
That's why it's a AND case. What is AND meaning? Multiplying. Multiplying means what? Branching out. Right? What is the meaning of branching out? For every one way, for a previous one way, I'm getting multiple ways further. Make sense? And that is the meaning of
Yes.
AND. And means branching out. And means together. Why together? I need the two slots can be occupied at a time together. I do not need one by one. I do not need the first slot or second slot. I need first and second together. First and second, right? I'm saying the both slots together, first and second. That is a permutation. I am counting it, right? So this is the meaning of what is the meaning of combination? Let's also understand.
Combination means
Ha, the,
number of different.
the combination is, I'll tell you what is the meaning of combination. Combination is NC, or how do we indicate? NCR. What is the meaning of this? Selecting, selecting R items from total N. Okay. So how many ways? So how many ways you select R items from N items? Make sense? So let's say we have like this
Yes.
5C2. Selecting two members out of five members. Selecting two members out of five members. How do we write? So 5 factorial divided by 2 factorial into 5 minus 2 factorial. So what is the meaning of this? So I'll get 5 factorial divided by 2 factorial into 3 factorial. So I can say 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. So I did not expand because we'll get cancelled. So 2 factorial is 2 only. 2 2s are 4. I'll get the answer 10. There are 10 ways you can select any two members out of 5. I'll give an example. Say A, B, C, D, E. How many members are there?
5.
5. So I must select how many members at a time? At a time, how many members I am selecting? At a time,
Two.
how many
Two.
members I am selecting? Two members, right? So can I say I can select AB, right? Or AC or AD
A.
or
AE.
AE. So I can say one selection is AB, other selection is AC, AD, AE. Make sense? Can I say
Yes.
also BC? Can say BD
BC, BD, BE.
and BE. I can say BC BD, BE. Can I say again CD and
Mm.
CE,
Yes.
CD and
C.
CE? Can I say again DE?
Yes.
So how many ways altogether? Can you count?
Mm, 10.
10. There's 10 ways. Okay, this is the manually you can solve it, right? But that one, that is the you can use the formula, I can solve it, 5C2, right? Now what is the difference in the P and C? Remember, always keep in the mind, the term is permutation, the term is combination. There's a difference. You know what is difference here? Very simple. So AB is given. Look at the first selection. AB and BA is the same selection. Why? Do you know
Mm.
why? Because it does not matter the order. AB is the same as the BA selection, because I'm selecting a group member, no, in a member. It does not matter who is selecting the first and second, right? So AB, I can say AB equals BA selection. This selection is same. But in the permutation, AB, arranging AB and or arranging BA is different, not the same. Do you know why? Because in the permutation, the order in which you put the person in matters. So here I'll count the two different ways in the permutation. Here I'll count only one way. In the combination, I'll count only one way. But in the permutation, I'll count two ways. Right? Because in the permutation, we talk about the arrangement. Different slots, how many ways you can arrange them. And that's why in the arrangement, the order matters a lot.
Yes.
Order matters a lot. But in the combination, the order in which you select does not matter.
Mm.
Makes sense? Makes sense? That's why I said BA and AB is the same. One way, only one way. But AB or BA arrangement is different. Right? That is a permutation. Making sense what I'm talking about? Okay.
Yes, sir.
Now let's try solving question now. Shall we?
Yes.
Let's go for one question. Go ahead. And also keep in the mind, whenever you see group, teams, the crowd, which means the combination, always. Whenever you see the arrangement word, right, that is a permutation.
Yes.
Let's do it this question. Let me solve. Question reads as a space shuttle crew consists of one commander, one medical officer, and one chief scientist. If there are 7 candidates for commander, 4 for medical officer, and 2 for chief scientist, and no candidate applies for more than one position, then how many different shuttle crews are possible? Now, first you tell me, is this question referring to the crowd, team, group, or referring the individual? Does this question refer the team? Yes or no?
Yes.
Tell me. Tell me. Yes or no?
Yes, sir.
Yes. Which means what kind of question is this? P or C? P means permutation, C means combination. What is the question?
Combination.
Combination. Very simple. Why is a combination? Because we're talking this question referring to the team, right? So in a crew members, right? Crew. See, talking about the group, which means the combination for sure. Which means I have to use NCR. Correct? No.
Yes.
NCR. What is the formula? NCR formula? N factorial divided by R factorial into N minus R factorial. Correct? Okay. Now look at the question. In a space shuttle, how many required commander? Only one. How many required commander? Required. Only one. How many medical officer required? Medical of only one.
One.
How many chief scientists required?
One.
One. Only one required here.
Yes, sir.
One required. One required, no?
One, yes.
One required here also. Correct. But out of this, how many we have the medical, how many we have commander altogether? How many we have commander altogether?
Mm,
See in the
7
question.
candidates.
We have a 7 commander altogether. How many we have the medical officer altogether?
Mm.
How many are there? Medical officer?
4.
4. Super. How many we have the chief scientist?
Chief scientist.
2. So out of 7 commander, how many I need? How many I need? Out of 7 commander, how many requirement is there?
How
1.
many requirements? 9.
Only
Sorry.
one, no requirement. Only
Yes,
one
sir.
commander is required. So out of 4 medical officer, how many requirement is there?
1.
1. Out of 2 chief scientists, how many requirement is there?
1.
1. So now we have a commander, only one requirement. How many are there? 7. So I will choose any one, right? There are 7 different commanders. Out of that, I'll choose any one commander. So how do we write? 7C1. So
Yes.
I am choosing any one among 7. So I am choosing any one medical officer out of 4. I am choosing one chief scientist out of 2.
Yes.
So I need the team all together, right? All together. Remember, together means what? Plus or minus? Plus or minus?
Mm,
Sorry,
all
plus and
together.
into. Plus and into. No, and. What is the meaning of and? Together.
In-
I need all together. Which means I need the 3 members in a shuttle cruise. Right? So together.
Yes.
So into. So what is my answer? 7C1 means 7. 4C1 is again 4. And 2C1 is again 2. So what is my answer? Will get 56.
Mm, 50. Yes.
That's your answer. Make sense?
Yes, sir.
The question reads as 6 children, 1 boy, and 5 girls must stand in a line. If the boy cannot stand first or the last in a line, in how many different ways could the children be arranged? Very simple. Look at the condition. Condition says that boy, how many all together? 6 children, no? So 1, 2, 3, 4, 5, 6. 6 children. So there are how many girls are there? There are 5 girls. How many boy? Only one boy. The boy cannot sit first and the last. The boy can sit here. Correct? If boy is here, so how many ways you can the girls can sit? 1, 2, how many girls? 5 girls. So G1 can be here. Let's say G2, G3, G4, G5. So girls can sit how many ways? Can I say 5 factorial ways? They can
Yes.
arrange among themselves, no? Which means 5p5. If boys will take second position, the girls can sit how many ways? 5p5. Because 5 boys and 5 girls and 5 slots. But remember, we have one more way for the boys, no? The boys can also occupy which slot? The third slot. If boy is here, then how many ways girls can sit again? Again 5p5. Correct, no?
Mm,
So
yes.
again I can say 5 factorial, or keep in the mind boy can also take the fourth position. Why not? Right? So again I can say the girls can sit 5p5 ways, which means the 5 factorial ways. Make sense? Now,
Yes.
or boy can sit the fourth position also, no? Then
Mm,
again the girls can sit 5p5,
mm,
5
yes.
factorial, and that's all. You add all together. Add all together. Which add The 5 factorial, 5 factorial, 5 factorial is nothing but 5 factorial into 4. Correct, no? What is 5 factorial here? The number of ways girls can occupy the position. What is
480.
what is a 4 here? 4 is the number of ways boys can sit. So I am multiplying because for every for every one way of the boy sitting, I have multiple ways of the girl sitting. Right? So 120 into 4, I'll get the answer 480. Make
Yes.
sense? Make sense? That's
Yes,
your
sir.
answer. That's your answer.